All right, so we're talking about chapter 10. This is scope. The the concepts in the chapter are not crazy, and when you play around with enough programming languages, you begin to see sort of different ways of handling scope. Let's just try to motivate it for a second, and before I even give you the next slide where it sort of dives in, there's some introductory stuff in the chapter that I quite like that is not in the author's slides, but I want to hit a couple of things. Scoping is really all about context. It's all about sort of differentiating. When you see something that looks like it might be the same, can I differentiate it, right? So the example that they give is, somebody says, "Hey, I ran into Bob yesterday," right? And and you're like, you're okay with who that is because there's enough of a context. Maybe you guys only know one Bob, or maybe there's only one Bob in your current sort of space, right? But we get into things all the time where we get struggles, right? I have a daughter named Sarah and a daughter-in-law named Sarah, for example. So yeah, I've got basically two daughters, both named Sarah. There's that old I don't know what it was, a television show where there was the three brothers, Larry, Daryl, and Daryl. There were literally two brothers called Daryl, and it was funny because we don't expect in families to have that kind of scoping struggle, right? So Larry, Daryl, and Daryl. I had a similar thing long, long ago where back in the days before caller ID, where I got a phone call from somebody, and I'm just like, hey, hello, this is Chuck. And they're like, hey, Chuck, this is Janet. Hey, Janet, how you doing? And we're talking for like a few minutes, 5 minutes. And then at some point, she's like, so you going to go to the thing tomorrow night? I'm like, what thing? And she's like, whatever it was. I don't remember. It was 35 years ago. But anyway, what we discovered was I did know a Janet. She did know a Chuck. She had called the wrong number, and everything was just matching. So it wasn't until we were going for a little while that we realized that she was not the right Janet and I was not the right Chuck. That's an example. So again, this is all about scoping. We can reuse names as long as we understand the specific scope in which we're going to use it. Okay, one last one, because the book uses Bob as an example, right? And they make this statement: although there are many people named Bob, this fact does not render all Bob-laden communication ambiguous. And in our department at UVU, of course, there are two professors named Chuck who teach this class. And you got to get the right Chuck. And anyway, when my wife was in college, her group of friends, there were two guys named Bob, and they were both tall and skinny, but one was slightly taller and the other one was slightly skinnier. So you had two Bobs in the same group. They were there all the time. The context, the Bobs were always there. And so their solution was to name one of them Tall Bob and the other one Skinny Bob. And so Tall Bob and Skinny Bob. And they would literally say things like, so have you seen Tall Bob? Have you seen Skinny Bob? And that was the way. Anyway, you get the idea. This is just about differentiation when you want to reuse the same name. If every variable name anywhere in any program was always unique, then we really wouldn't care about this. It wouldn't be a topic, okay? But imagine that every single time you try to do a for loop in C++, you could use I the first time, and then you could never use I again. You'd have to use, I or I or I 1, 2, 3, 4, etc. Right? Just imagine. It would be mass hysteria. Okay, so that's really what this is all about. So here's a couple of examples, right? So here's putting it into a programming context, and this is ML. I can declare a function called square, right? I got a parameter called a. I've got two values internal to the function, a times a, or you could argue it's the same value, which I think that's a reasonable argument. And then if I've got another guy that goes double b, b plus b, no conflicts. But what if they're all n? Well, the truth is, I really shouldn't matter, should I? If I say square 5 or I say double 7, right? I shouldn't have to worry that on the inside that double's got a bunch of guys named Bob and square's got a bunch of guys named Bob, but they're not the same guy, They just happen to, so I don't have to call up and say, I need to talk to Bob. I just need to call up and say, I need to order a pizza. And then I don't care if there are, guys named Bob working inside your Little Caesars or not. And there's also guys named Bob working inside the Subway, right? I hope that makes sense. So here's where we're going to go. This is the overall overarching kind of table of contents. We're going to do definitions and scope right now in this podcast, and what the rest of these are going to do, the other 5 sections, and there'll be 5 separate podcasts, I think, based on size, is different ways of solving the problem, different solutions to the problem, okay, of scoping. So we're going to start with just a few definitions and make sure we know kind of what we're talking about from a programming languages perspective. Okay, so definitions, what are we talking about? So again, when we've got different variables with the same name, from the perspective of what we've been talking about, and the way the author approaches this is to look at this as different possible bindings, okay? And especially in ML, we're not just talking about variables, we're talking about anything, constants, function names, type names, anything, right? So a definition then, and this is a little clunky, I don't know, maybe a little bit, I don't know, slightly complex or tricky, but try to get your head around it. A definition is anything that establishes a possible binding for a name. In other words, a definition in our context here is some situation in which there's a name and it might refer to something. So when we say that something is bound to a name, there's a function and I bind it to a name, I'm really just saying that's something that the name now refers to. If I bind a value to a name, right, by saying like val x equals 7, I'm taking the value 7 and I'm saying that is what this name x means now. That's what we mean when we talk about binding, right? So here's an example, right? I've got this one where I could say, again, function square n equals n times n. But can I do this? Function square equals square times square. Because I've got a function called that I can, call square. I've got a parameter that I can call square. And I've got the interiors, those interior values, which really are the parameter, that are called square. And the real question is, how do I deal with that is the question. Here's another example. This is from Pascal, where I've got constants like low and high. I've got a type that I declare called ints. And I've got a variable called x of type ints. Well, so first of all of these are within the same scope in Pascal. So when I declare low and high, I can use them in the definition of the integer type, or the type ints. Then I can use the type ints when I'm trying to articulate, what the type of x is, right? And I'm declaring x as a variable and making it of those type. This scope all handles all of that. But what if I want to use low somewhere else in the program? What if I want to use high? Same idea, right? So just to kind of reiterate, and we're just kind of setting this thing up, and then we're going to jump to the various possible solutions, okay? So there, again, just as kind of beating the horse here, but there can be more than one definition for a given name, okay? And then every occurrence of the name has to be bound, okay, to something. And then the occurrence of the name is in the scope of a given definition of that name. And this is the kind of the more formal definition. An occurrence of a name is in the scope of a definition of that name whenever that definition governs the binding for that occurrence. It's a little bit of a dense statement, but here's kind of what that's trying to say. When we talk about governing the binding, we're basically saying when I'm at a party and there's only, and I'm at a birthday party and my brother Bob is there, I do have a brother named Bob, then if I just say, have you seen Bob, then the party context governs that. If I'm in a different context where there's another Bob at work and I'm at work and I say, have you seen Bob, it's a different context. And so that there's a different environment, okay, that governs the binding for that occurrence. So when I say Bob at work, then Bob is bound, the name Bob is bound to the guy I work with at work. If I say Bob at a birthday party for family, then the name Bob is bound to the individual who happens to be my brother. Okay? So what we're talking about, and what we call that is scope. I think an easier way to say this definition is that there's a work scope, there's a home scope. The Bob at work and the Bob at home are not the same Bob, even though I would write their names the same string, but there's a binding. I hope that makes sense. And then we just kind of end on this for this podcast. It winds up being a very short one, but just trying to motivate it and set the thing up. Okay. So here again is that example of fun square times square. And then we go square 3. And ML is okay with this. Okay. You can try this code. And, but what the heck, right? And how do you, so this point is that every occurrence has to be bound using one of the definitions, but how? That's really the question. So this isn't solving that, it's just setting it up. So that, and I want you to go ahead and try this and just show yourself that this works. And then just like, what are the rules? What are the rules that ML decided to employ? Because with programming languages, we can do kind of whatever we want. We can do whatever syntax we want. We can have things mean whatever we want them to mean. And this is just an example of a classic programming languages problem that we have to get our heads around and understand in order to understand programming languages when we see them coming at us from, in different languages, different environments, etc. What we're going to do is now kind of settle into these 5 topics. There'll be 5 additional podcasts, and we'll break these down as ways of solving the scoping problem.